Hi guys, and welcome back on my YouTube video channel. And today's lesson we are going to discuss assumptions that we use in strength of material course and in finite element analysis. Right from the beginning, I would like to ask you not to be afraid of this course strength of material. Please have in mind that it is based on many assumptions and simplifications, but these assumptions are sufficient for a big number of practical applications and for finite element analysis. Strength of material is a subject which studies the behavior of solid objects subjected to force. It helps us to evaluate the stiffness and strength of a body. Today we will talk about two assumptions. The first one is, we assume that all bodies are fully filled of matter. It means that, for example, a body made of steel or concrete is fully occupied with matter and there are no cells or hollow space in it. In other words, our body is solid body. But in real life we can't be sure 100% about that. So let's look at this picture. It is a concrete. If we have a look a little closer, we might see the picture like this. Therefore, in calculation we don't really pay attention that our body like a cheese. In fact, we only use some coefficients that lower our allowable in analysis. The same we can say about steel, and again, if we have a look a little closer, we might see that the structure is not fully occupied with matter. The next assumption is, we assume that our body is homogeneous and has a similar mechanical properties in any direction. In other words, the matter is isotropic. Here we need to keep in mind that this assumption is applicable not for all materials. For instance, steel is isotropic material. Let's imagine we cut out a part of it and load it in different directions. In this case, it doesn't matter for us, because steel is an isotropic material and behaves equally. I think you might be curious, what is an isotropic material? And this is a good question. Unlike the steel, we have a wood and composite materials. These materials have a different properties depend on in what direction the load is applied. Let's imagine we apply load in different directions. We will apply along and perpendicular to the fibers and see what will happen. Due to load along the fibers, the specimen is compressed and fibers are distorted. By the way, here among the fibers a crack may appear. In the case when the load is perpendicular to the fibers, the specimen may only be pressed. Okay folks, we discussed these examples and you see that there are many uncertainties. But in spite of them, we still use these assumptions, because they are proved with experience during big period of time. There will be more assumptions and we will talk about them next video. Subscribe on my YouTube video channel. If you don't want to miss a new video, press the button share it and like it. Bye guys.